Okay, good evening, everyone. Thank you very much all for joining us tonight. Tonight, the topic of our webinar is successful factors for robotic milking. And as a guest speaker tonight, we'll have Jack Rodenburg from DairyLogix with us, which is a kind of a fantastic speaker that we have. And hopefully you'll enjoy tonight. The webinar itself is organized by Lely Center, Devon and Cornwall. And we're following up from a previous webinar where we spoke about dynamic feeding and kind of feeding of dairy cows on robots. With the thing is actually, the question is what makes actually robotic milking successful? Because we all in a way have the same machine, and some people are very successful and others are always kind of like maybe not as successful as they would like to be. And hopefully tonight, Jack will be able to help us to identify areas where we can look into and also where we can make progress. If you have a question, if you could put a question during the talk in the chat, then we collated the questions, and then when we have a little break later on, I will put the questions for Jack to be answered. And at the end of the talk, we also have kind of a bit of time for open questions if there's still any questions left at the end. So from that point of view, the meeting will be recorded, and we will all send you a link of the recording so that if you want to listen to it again later on, you can have at your own time, you can listen to it. Or if you are not able to make tonight, you will still be able to get this talk to you. So as a program for tonight, we have Jack kind of talking about the successful factors for robotic milking, which is split up in a general management strategies, a bit about feeding, a bit about barn design and barn management, and then also questions and answers. A little bit of background on Jack. He from like 1974 to 2008, he worked for Ontario Ministry of Agriculture. And over his time there, he developed his expertise in dairy nutrition, water quality, barn design, and robotic milking. And if I'm not mistaken, also one of the first robots in Canada, America, was installed just down the road from him. Jack retired from his role at the Ministry of Agriculture in 2008 and started the DairyLogix consultancy business with the focus on designing dairy barns for cow comfort and labor efficiency. And also he started lecturing on robotic milking and other dairy automation and precision technologies. Jack himself is a CowSignals qualified trainer and also has co-written 3 books in the CowSignals series, of which the first one is Robotic Milking, which I have to say is also available in red, Building for the Cow, and also Feeding Signals. So I'm very pleased to see that Jack is with us tonight and that he made time available for us to talk to us. So what I now will do is kind of like stop sharing my stream and hand over to Jack.
Okay, well, good evening. And I am looking for the screen sharing button now.
Yeah.
Which I'm not finding. Show taskbar. Okay, well, I think we should just get right into the presentation, and you'll have to survive without looking at me because we haven't figured that out, how to make that happen. But just as add a little bit to the introduction, I advise farmers on all brands of robots in terms of barn design and management issues and so on. I probably have a stronger connection with Lely than with some of the other companies. My son is a Lely dealer, West Coast Robotics in British Columbia. And he actually has a dairy with 30 robots in operation. I think it's sort of the biggest single installation that I'm aware of. My daughter is a dairy farmer married to a veterinarian, and she's milking in about a 50 cow sand-bedded freestall barn with one Lely robot. So certainly hands-on experience is more likely to be Lely than one of the other brands. In terms of how I got into this as a consultant, I am having problems here finding a mouse. No, I'm not. Okay, well, we'll just advance the slide and see if that works, and it doesn't.
No, at the moment we see you, Jack, and not your screen at the moment.
Okay, and I see just my slide. So display settings, swap presentation and show.
Yeah.
Is that what does that help us now? What do you see now?
Well, I'm still seeing you at the moment.
You see me.
Yeah.
Okay.
And if you click, if you unshare your screen and share again, that sometimes can help.
Yeah, but I can't find the screen sharing button.
Oh, if you either hover along the bottom or the top of your screen.
Yeah. Okay. Now I have that display, and you're still seeing me?
At the moment, yes.
All right. Well, then let's just say hello.
Hello.
And then if you have seen me long enough, I will switch to, there we go. And what do we see now?
I can see your slide now, Jack.
The presentation. Okay.
Yeah, so we're good to go.
After this long delay, let's actually get started on this presentation. So, yeah, my passion in terms of the advisory work that I do is clearly on robotic milking. And so I will be a little frustrated. We only have an hour and a half to talk about this. I have intentionally limited the number of slides so that we do leave some time for questions, but I do encourage you to put them in the chat as they come to you so that we can get at them quickly. I actually want to take a break in the middle of the presentation to talk about some of your questions there and sort of have a chance for you to stop listening and participate. So I want to talk about success factors for robotic milking. You know, I wonder myself how one should try to measure that. And I have said the first criteria has to be that we're looking for a happy farmer as a customer. And so I think a lot of things to do with robotics have to do with lifestyle. And so the thing has to work well for the customer to be happy. And so that's my first priority, is have a system that works well, minimal alarms, minimal fetch cows, and so on and so forth. Secondly, it has to be profitable. And essentially with what we pay labor in Canada, that has never been an issue from day one. I also work with a lot of clients in the US, and there, if I go back 20 years ago, you probably could not justify the cost of robots on a large dairy that efficiently milked with a parlor. Today, I think that too has changed. And anyone in the US paying $12 to $15 an hour for labor can justify replacing that rotary with robots on cost alone, and gain a whole lot of other benefits in terms of improved cow comfort and so on. I think we need to focus on high production per cow in the kind of environment that I work in, with intense dairy farming, housed cows, fed a diet that's fairly high in grain. We need to find the best feed efficiency. We need to find the best labor efficiency. And that for us comes with high producing cows. I realize that if you're in New Zealand or if you're really strongly grass-based, and focused on pasture, you're more interested in production per acre than production per cow. But that's certainly not what I work with most of my clients. I also think you want to be able to achieve high milk production per hour of labor. So, I mean, the goal of robotic milking is to reduce your labor requirements, and it can do that very well if things are properly organized and so on. The goal that I read a lot about and hear a lot about that I have some questions about is focusing on high production per robot. And I think that while that is, financially rewarding, I think it is often overemphasized. If you put too much emphasis on production per robot, you're going to push too many cows through. And in my experience, if you have less than 8 to 10% free time, you're going to get fewer milkings per cow, and that will hurt your milk production, especially on fresh cows. You're going to have more fetch cows, and so your labor goes up fairly substantially. And if I look at cow health, for example, and cow comfort, you're going to have longer waiting times. And if cows spend an extra hour a day waiting in the queue to get into the robot, that's an hour less they can spend laying down and making milk. And so that also hurts production. That might hurt longevity of the cow and reproductive performance and so on as well. The other point is that if you ever have a stoppage, if you have an alarm or a robot down, the busier those robots are, the longer it takes for you to recover the milk production that you lose. And I think that poor recovery has a fair cost to it as well. So if I look at today's climate for farming, borrowed money is relatively cheap. Interest rates are about as low as I can remember over the time of my years in business. But feed and labor are increasingly becoming more expensive. So I think it makes very good sense to invest in adequate robot capacity and always make sure that you have that 8 to 10% free time available. In terms of comparing robotic milking to milking parlors, where most of us would come from before we invest in robots, I think things are different because milking is voluntary. And so milking intervals become variable, and that just changes. You need to change the way you think about some of these things. And you definitely need to minimize these long interval cows. So these cows out here that are sort of 13, 14, 15, 16 hours and beyond, these are likely to be the fetch cows. These are likely to be cows that don't produce what they should because there's too long a time between milking and so on. And when milking time is variable, and it is under your control to some degree because you can set the minimum milking interval, but beyond that, the cow chooses when she comes. And so, here's an example of just 4 cows. And we can say these cows are eligible to come every 5 hours, the way the computer is set up. And so you have cow A that comes every 5 to 6 hours and gets milked 4 times a day. And if I look at what the literature says, you can expect as production compared to twice a day milking, that cow is going to produce as much as 18% more than she did 2x in a milking parlor. Okay, the second cow down, B, she's milking 3 times a day. And if we're parlor people, we think, oh, that's, we're going to get 10% more milk, 10 or 12% more milk from that compared to 2x. But that is with research that has the cow milked every 8 hours. And here's a cow doesn't come at all overnight, comes twice during the daytime. So yes, she is milked 3 times a day, but because of the high variation in the milking interval, in my experience, she's only going to produce about 6% more than she does on 2x milking. Cow C is milked twice, but it's not in the sort of 12-12 or 11-13 interval we might milk in a parlor. She's actually going to give a little less milk. And cow D, that reluctantly comes or gets fetched, could give as much as 6% less milk. And when you look at this as an average, the average milking interval is 9.3 hours. The milkings per day is 2.65. That sounds like it's quite a bit better than 2x, but the milk production is going to be disappointing and very close to 2x milking. So in terms of what I think we need to do with robots, or what we need to aim for, it's going to take an average of 2.5 milkings a day just to match 2x production, and about 3.1 milkings per day to match 3x parlor milking at 8-hour intervals. So I think you need to make 3 milkings a day your target in the kind of housed intense production herd that I think you have in England and that we certainly have here in North America. But when I look at these numbers, it's clear to me that uniform intervals are just as important as milking frequency. So you can't just take that 3 milkings a day and say we're achieving our goals. It has to be with the majority of cows milked at uniform intervals. So if you can get your fresh cows milked 4 times a day, your mid-lactation cows 3 times a day at 8-hour intervals, and your late lactation cows twice a day at 12-hour intervals, I think you're living in an ideal world as far as the goals of robotic milking is concerned. So how do we optimize robot efficiency? I've said it's not my primary goal, but obviously you want to succeed to a degree with it. So you need to keep the box occupied with high milk flow rate cows, and those are high producers with above average milking speed. So milking speed is something you should put some focus on. If you don't have robots now and are planning to invest in them in the next 2 years, take a look at culling some of your slower milking cows, because they do take up a lot of robot time. Milk fresh cows and high producers more often and lower producers less often, and manage milking permission for these cows closely, like reduce milking permission for a very slow milking cow in order to free up more space for others who will reward you with more milk if they get milk more often. One thing you should not do is skimp on prep time. And virtually all of my clients use a prep routine that takes the brushes around twice. A well-prepped cow has full teats at attach, and so she attaches better. I'm not going to make this a commercial for Lely, but to me, one of the benefits of the Lely system is that when you prep the cow with brushes, then the laser and teat cups are looking for teats that are full of milk, and they're much easier to attach to. And the cow will milk faster. So I would put emphasis on prepping the cow well. Minimize failures by keeping udders clean and free of hair. So our herds here, especially in the wintertime, traditionally will lock up once or twice over the winter and singe the udders to remove the hair. And any cow with calving that has very much hair in her udder will get singed in order to clean that hair off. And then, good bedding, well-maintained stalls to keep the udders clean. That's going to improve attachment speed and attachment success. Cull slow milkers, milk them less often. And I think Lely has software to optimize milking interval, and that will capture some of the individual variation and so on. This is really, really old numbers. It's almost 20 years old now, but I think the same truth still stands there. 60 cows, you can milk 60 cows, typical cows on most robots, and have very low numbers of fetch cows. And with today's technology, that should be down around 2 or 3% of the cows that you end up fetching. But look at when you push beyond that in this data, these herds are fetching a lot more cows, and it's a lot worse than a straight line. So that's a risk that you run into if you try to put too much emphasis on robot capacity. I think when I look at all this data, if we want cows to attach well, we want cows to milk quickly, A lot of that is genetic, and there is a genetic component to this. And, again, if you're looking at robots down the road, putting some emphasis on the right traits now could help to make sure you have the right cows when you get there. Now, I understand in Europe, uh, some of the AI studs are actually proving bulls for lower box times. And that's, I think, a good step in the right direction. So you want to lower box time to create more free time, allowing you to milk more cows. So what do you look for that? You need to choose cows or bulls that offer higher milking speed in their daughters. You want good teat placement to get good attachment, and I think average to large teats. And teat size on Holsteins today, at least in North America, is a bit of a problem. They could be a little bigger, and lasers would find them easier. I'm also interested in finding ways to select for aggressive visiting and uniform milking intervals. And right now, I see some fairly, theoretical, robot indexes that emphasize good feet and legs and so on. And that's logical. But the heritability of voluntary milking frequency is pretty good. It's around 0.2, depending on stage of lactation. And so you can, if we had the information, select directly for cows that aggressively want to visit the robot. And if we did that successfully, we would have fewer fetch cows, and we would have an easier time managing milking intervals and so on. And right now, no one is doing that. So if any of you that are listening have any influence with the AI industry, I think we have the data. Robots generate data on milking intervals, uh, but we're not using it. And you can prove AI sires for their daughter's interval from milking permission to milking. So if this cow is eligible to come back and be milked 8 hours from the last milking, and she comes back in 8 hours and 2 minutes, that's a perfect cow. Okay, that's exactly what we're looking for. And the length of that interval, I think, can help us find the right cows for robotic milking in the future. So let's take a look at some management things that are going to influence whether this cow comes frequently and aggressively and happily. And essentially, my CowSignals training says we need a healthy cow, a cow that has good access to the robot, and a cow that gets rewarded for showing up. So when we're talking about the healthy cow, certainly, udder health and metabolic health and so on are important, but the one that's the most obvious is lameness. And lame cows just are not going to come to the robots voluntarily with the frequency that we want. And we don't have time today to spend a lot of time talking about what causes lameness, but certainly nutrition is a factor. You want a diet that's high in digestible fiber, relatively low in starch. To prevent laminitis, you want a diet that provides the proper balance and adequate levels of minerals and so on. Cleanliness of the barn. Cows with dirty, wet feet are going to have a whole lot more lameness issues. So the barn needs to be clean. Genetics, you want good depth of heel and good structure to the leg. Cow comfort is absolutely critical. The more time this cow spends laying down in a stall with her feet drying, the less time she spends standing in a manure-filled alley with bacteria and foot rot issues and so on. Good management is going to require regular routine foot bathing, and we need to make that simple. That's a bit of a challenge in a robot barn. And then when you have a cow with a problem, it has to be easy to separate her and trim her and treat her and so on. And hopefully, as a farmer, you will have some of those skills yourself. Because if you're totally relying on hoof trimming by a professional coming in, that just doesn't happen often enough. The foot bathing, I think, has been a real challenge, and I've seen different solutions offered. I think we've learned early on that foot bathing at the robot exit is not ideal. It discourages visits. When the cows see the foot bath, visits will go down, milkings will go down by 0.3 to 0.4 on that day, in my experience. And in free traffic, it just doesn't work well because the number of passes is so highly variable. So an aggressive cow with really great legs, she'll be milked 4 times and refused 3 times. So she gets 7 passes through your foot bath. That's more than enough to dry her feet out and maybe a problem. And she might manure in it twice and ruin it for the other cows. Whereas the cow that really needs the attention, she only comes twice when you fetch her, and so she's not getting the level of exposure to the foot bath that you're looking for. What a lot of herds have done, and what most lady dealers in North America recommend, and it's certainly not my favorite choice, but what they're saying is that if you put a foot bath in a crossover at the far end of the barn, away from the robots, and then once a week, you gently walk all the cows through it. Then you have a system that's less disruptive to robot visits. All the cows get the same number of passes, so that's a plus. The chemical is fairly fresh, and that works better, and the chemical is away from the milk and the metal parts of the robot and so on. And if you combine this with bedding delivery strategically, so that, I mean, that might be a time that you want to move cows from one alley to another anyways, it can be done without a lot of additional labor. So essentially, you come to the barn in the morning, you chase the cows out of the alley along the manger, you bed that alley if there are stalls there. Then you open the foot bath and put down fresh feed, and most cows will walk through on their own. You chase through the stragglers, and then you bed the back alley before the cows return there. I think doing this single file, especially with a bigger group like 120 cows on 2 robots, can be quite stressful. Because if you are doing some herding, the cow you're pushing is way far away from the cow that's deciding to go through the bath. And so that's a stress. It's also a very inconvenient location for foot bathing special groups, like say a lame cow that you're housing in a bedding pack behind the robot, or a fresh cow that's housed there. They're nowhere near this foot bath, and you have to mix them with other cows to get them through this foot bath. So those are some of the reasons that I'm not a big fan of this. If you are going to do it, a wide bath will reduce the stress, especially for larger groups. So here is a bath that's sitting on a set of hinges. And when it's lowered down with a cable, it covers the full width of the alley, and cows can walk through there 4 abreast or so. Much less stressful, does waste a bit more chemical because you need a lot of solution to fill that bath. So here it would be my choice, or my favorite option. So if you put the foot bath strategically across the end of the robot room, so at a 45-degree turn, or sorry, 90-degree turn from the cow at milking, then the cow that you choose to not foot bath at that milking can exit straight through the one-way gate at C, like that. The cow that you're sending to a separation area can follow that light green line through the 2 one-way gates and into the separation pen behind the robot. And the cow that you are foot bathing with a 3-way sort, so a second sort gate at D, that's also controlled by the computer, that then will turn her right at that point after the footbath back into the herd. And with this, you can use the separation function to footbath the cow 2 passes or 1 pass, and then leave her again for the next week or whatever. So you can now choose the frequency of foot bathing a cow depending on the quality of her feet and the particular situation at the time and so on. You're going to say, I don't know, how do we do this with a couple of robots, and do we need this complicated 3-way sorting at every robot exit? So here's a robot barn with 2 robots, one on each side, both facing the same direction. And if you look at the arrows, a cow from robot 2 can be separated into a lane that puts her in the fetch pen of robot 1. And then she will pass through robot 1, be refused, and be directed through the footbath back into the barn. So here's that same setup as an L. So do a lot of 120 cow groups with these L layouts like this. So there's a cow exiting from robot 1, being directed through fetch pen 2 through robot 2 for a refusal, and then turned left at the sort gate and turned right at the second sort gate to put her back in the herd. And some of the dealers I work with say, well, it's a concern that half the cows in this group now have to go through this refusal in the second robot. But in my experience, like that takes at most 10 or 12 seconds. And in a 120 cow group, that amounts to 2 milkings on the day that you do your foot bathing. The other thing I see herds doing with this is that they don't foot bathe all the cows on the same day, and that improves overall traffic a bit and also makes it more interesting from the standpoint that the cow has no idea whether she's going to go through the footbath or not. So it cannot reduce her willingness to go for milking. So do cows have good access to the robots? I am a big fan of free traffic. I do not like guided traffic barns. I do not like commitment pens. I think a cow from the herd should be able to go directly into the robot when she chooses, with the only obstruction being a higher ranking cow that wants to go before her. And what I see in the research as well is that these kind of free traffic barns have less standing and waiting and more resting time for the cows. That makes for more comfortable cows, less lameness issues, and just better visits and better traffic. There might be a few more fetch cows, but you know, a new fetch cow can offer some early diagnostic advice, because quite often a new fetch cow that you haven't fetched before, when you fetch her, take a good look at her udder and take a good look at her feet and the way she walks, because she might very well be a new case of lameness or a new case of clinical mastitis, and that's what's causing her to stop coming. In my experience, and we can talk about, you know, guided versus free traffic for an hour, we could, but in my experience, when things go wrong, you know, when things go well, both systems work well. But when things go wrong in a free traffic barn, the farmer suffers because he right away has more fetch cows. In a guided traffic barn, the cow essentially has no choice. It's either go and get milked or starve. And so because cows suffer longer waiting times and less rest, you're interfering with cow comfort. In my mind, I would rather see the farmer suffer than to see the cows suffer, because I'm also convinced that if the farmer is suffering and having to fetch more cows, he's going to be more interested in solving the problem. But cow comfort is just absolutely critical to success of these barns. And so in my mind, cow comfort comes with free traffic. And so I personally would always choose for free traffic. Want to talk a little bit about the milking stall itself, and can we encourage visits if that milking stall is more attractive to the cow? I think definitely yes. Some of the factors that come into play there, we like to put some extra ventilation there. In this picture, I show the fans on top, over top of the cow. Thinking about it today, I would probably put them over the rump of the cow for a couple of reasons. I think you more effectively cool a cow when you blow air along the length of its body. And it's probably more comfortable for the cow if you're not blowing it directly into her face. And in fact, the hottest part of the cow during periods of heat stress is that rear udder. And there's actually research data out of Hawaii that says their pastured cows during heat stress stand on the top of the hill with their udder into the wind, acting like a radiator to cool the cow. And so that's where I want to direct some of that air in the robot. Now, I've had ventilation experts tell me, well, wouldn't it be nice if we put some nice big fans or maybe some ventilation tubes or whatever over that space right in front of the robot so that the waiting cow can be more comfortable. And I think that's very dangerous. I would like the whole barn to be comfortable, but the last thing I want is to have cows come and gather close to the robot because it's the coolest place they can find and the most attractive spot in the barn. Because if you want something to interfere with cow flow through a robot, then for goodness sake, let's park 40 cows there that are just standing there in order to cool off. And so part of my design philosophy is that I want to make the robot attractive to the cow. I want to make access convenient, but I would like to place everything else other than perhaps the water trough as far away as I can to encourage cows to get their back rubbed somewhere else and to find their feed somewhere else and so on, so that you distribute the cows nice and evenly over the barn. Looking for a level entry, no big steps into the robot because that's stressful for a cow. Most of them now come with a rubber floor installed, and you want it positioned so it's highly visible from the barn so that a low-ranking cow can make a decision from wherever she is whether this is a good time to go or not. This question of is the cow comfortable in the milking stall, and this will be one more little plug for Laylee perhaps, but when I look at a Laylee A4 or A5, the cow is free to move around. There's nothing touching her butt. There's no butt plate that determines where her udder is. There's no indexing feed manger to push her back and force her to stand in one spot. And that freedom, I think, makes the stall much more attractive. And I know I've had clients who took out A2 robots and replaced them with A4s, and the A2s had the butt plate and the indexing feed manger. And with no other changes, same barn, same feed, same cows, they went from 2.65, 2.7 milkings to over 3. And I think this comfort in the box is really, really critical in that regard. Now, if you're working with a brand that does have a butt plate and does have an indexing manger, then you need to manage the adjustment of that indexing manger so that that cow can stand with her back flat and not be really pressured and stressed. And as the heifer grows, you need to adjust that at the following lactation and so on. Some of my clients that have these kinds of robots, I've gone in and just unilaterally opened the box up by one setting, and it takes about 2 weeks to get past the adjustments of that because the udder floor changes then in terms of its position. And so you need a little bit of time to get the attachment working well again. But once you get past that first 2 weeks, visiting behavior improves and milk production goes up and so on as a response. Does the cow get a reward in the robot? And that's why that feed is there primarily. And that's why it has to be something palatable, hard pellets with no fines. If I look in this particular picture, that is a very bad thing to find. You don't want that powder there because cows have a very hard time eating that. And part of your robot management should be to just every time you walk by there, check to see whether there's leftover feed. And if there is a lot of it, yeah, it's probably a bad sign. Still read a lot of research that says, you know, these cows consume this amount of grain, and this cow ate that, and that cow ate that. And, you know, if you see this, you have no idea what the cow ate because the one cow left it, the next cow is going to eat it. So it's not, you know, it takes the total control of things away from you. So hard pellets with no fines. In our experience, barley and oats, the higher fiber grains, tend to result in stronger pellets and work a little better than maize. Don't add fat. Fat is not palatable for cows. And limit the concentrate in the PMR so that you keep cows aggressive. And so I do think how you manage feeding is very important in terms of getting the right visiting behavior. Probably the most important factor in my experience. Pellet delivery, I think you want to use 2 bins per feed type and empty the bin completely, because repeatedly people get into problems when the bin is refilled regularly before it's empty. And then the day comes that you try to empty that bin and you get all kinds of gunk and stuff that doesn't flow. And all of a sudden you have no feed going to the robots. So if you can alternate emptying bins, that just makes for a much better way of handling feed. Bend flex augers in the same direction as they turn. That reduces the amount of crushing and the amount of fines they create. And I really like these chain disc conveyors that you see in the little top picture on the right. They do cause less fines than flex augers. Calibrate the system frequently so that you know what cows are actually eating. And I know the systems now have limit switches in them and warnings when there's no feed flowing. For years, I recommended using clear plastic hoppers on top of the robot, as you see in the lower picture, so that you could always see whether there is actual feed there or if it's just an empty auger spinning nothing to the cow. Feeding recommendations, I think Laley's been fairly clear about that over the years. You balance a partial mixed ration or a PMR at about 8 kilos of milk below the group average and feed that free choice at the manger, and then feed 2 to 8 kilos of pellets in the milking box according to production. And that gives you the best sort of balance. You go a lot higher with the concentrate in the milking box. It gives you more flexibility, and so there can be some savings in feed costs there, but you start to run into the cow not being able to deal with the feed speed. And if you've got an excellent quality pellet, I think you do want to play with the feed speed and monitor it closely and see what these cows will eat in the short period of time they're in there for milking. Because if you push that envelope, I think it can result in lower feed costs and higher milk production. Another option, which is perhaps a little old-fashioned and so not that popular, but it makes a lot of sense, is to feed the concentrate all according to production in the robots and in computer feeders. And so, you know, the cow can't eat all the grain she needs in the robot because she doesn't have enough time. If you then give her access to a computer feeder afterwards, you could feed nothing but forage in the manger And that is really going to help to keep late lactation cows coming regularly and frequently. That's, people say, well, can we go to cheaper feed and use mash rather than pellets? If you go this computer feeder route, you give cows the time to eat their grain, and then the answer is yes. If you don't, I think you're always walking a very dangerous line of not being able to get enough concentrate in the robots for your higher producing cows. In terms of those computer feeders, they have to be branded and linked to the robot so that the cow who goes to a computer feeder who's eligible for milking doesn't get anything out of the computer feeder. That becomes an extra signal to say, you've got to go to the robot and get milked before you're going to get anything more here. I encourage farmers to pay close attention to body condition and keep a thin cow, a thin open cow, especially on your lead feed table longer. But that puts the emphasis and onus on you to switch them back when condition improves. I think for many herds, you can lead feed healthy cows a little more aggressively, and that's something you can experiment with and increase the feed speed of these pellets if it's high quality and you can manage to make that work. But yeah, I think body condition is important. Here's a picture of two cows that are actually fairly close to the same stage of lactation and producing the same amount of milk. And very clearly in my mind, that black cow on the right deserves to stay on your early lactation feed table, and the white cow in the stall needs to be curbed to ensure she needs to be fed according to production at this point. So regular condition scoring should be part of your routine. I think the other thing I want to kind of sensitize you to is that when milking is voluntary, the relationship between feed intake and production and health and behavior and so on becomes more critical. We all know that high feed intake causes high milk production. And that's why we push up feed frequently and work at getting the best quality feed and so on and so forth, because we're aiming for high milk production. But it's not just a straight causal relationship, because if we milk more frequently, we get higher milk production, and guess what? That then causes the cow to eat more feed. So these things are all related, and it's like a spiral in a sense, that if you increase milking frequency, you increase milk production, you increase feed intake. And when something bad happens, like say when you have a heat stress problem and cows don't want to come for milking frequency goes down, milk production goes down, the interest in feed goes down, and milking frequency goes down again because the pressure to be milked is lower and the interest in feed is less. And so, these things are all interrelated. And so, fixed milking intervals in a milking parlor, when you drag that cow to a parlor 3 times a day and suck the milk out of her, that stimulates her appetite and that stimulates her to eat. And a robot, you don't have that. Okay. And so you need to make sure that the conditions the cow is working under are as good as we can make them, and encourage them to eat frequently all the time and visit for milking frequently all the time, and so on. So minimize heat stress, maintain foot health, maintain udder health, stimulate appetite by managing body condition and proper transition feeding, and avoid metabolic disorders. And we could do 10 more lectures on almost any one of those topics. But I'd like to take a quick break here. The rest of this talk is going to be about barn design. And so maybe we can answer some questions or have some discussion on general management, feeding, and genetics at this point.
Okay, Jack, thank you very much so far. I had a question here from what impact on udder health have you seen due to irregular milkings?
Okay. I I'm going to say that I have not seen it to be an issue, uh, other than specific linkages going back to the very early years of robotic milking, when there were clear failures and faults and so on happening. If I look at data on installations in the last 10 years, generally, somatic cell count in these herds either stays the same or goes down. And generally, we do not see any kind of increase in clinical mastitis. Uh, so I don't think that the kind of variation in milking interval that we see in a well-managed robot herd is going to create issues for udder health.
Okay. And then following on probably on that question, is there in a way that we can milk too often the cow? Because like we said, like 3.1 to get an increase on 3 times a day milking.
Yeah.
If we go over 3.5 or even to 4 on herd level, would that be an issue that we actually milk the cows too often?
Yes, I think that can be an issue. If you milk lower producing cows too often, there is a potential that you start to see more teat end erosions and issues with teat quality that can contribute to mastitis. Certainly, we found that there are milk quality issues when you milk lower producing cows too often. Changes in the characteristics of the fat and more free fatty acids and so on. And of course, if you allow too many cows too much access, you create a situation where you milk the aggressive cows often and the unaggressive cows less frequently. And that might not be the right approach to get the most milk. You want to milk the high producing cows more often, not the more aggressive cows.
Okay.
So can it be an issue for the cow? Yes, I have no problem milking a cow 4 times a day in early lactation. And probably 100 days so or in 100 days into lactation or so, she's not going to warrant it anymore, and then you'll want to be moving her down to less milkings.
Okay. And at the beginning of your talk, I believe you mentioned your son is working on a farm or has a farm with 30 robots.
Yes.
In your opinion, is there a limit on how many robots we can have on a farm?
No, I don't think so. I think it is the modern and futuristic way to milk cows, because you can milk the cow in a comfortable environment without making her walk a long ways to a milking parlor and stand and be stressed in a holding pen and so on. So in terms of farm size, there's going to be some limitations depending on where you are on how practical it is to move manure longer distances and to move feed longer distances. But in terms of robotic milking, if you milk them in 120 to 180 cow groups with 2 or 3 robots, you can put as many of those groups on one dairy as you want, and it'll function well. Other than these issues related to how far you move materials.
Okay. And I got myself a question on separation area, but I think I hold fire on that one as you're going to do barn design in your next part. So I will kind of like keep that one. If there's any more questions, if people can either type them in the chat or maybe unmute themselves, and I'm sure Jack will take a question from you before we carry on.
Yeah, I have a question for the group as well, and I don't think we can get into a huge discussion with 80 or 90 people listening. But this is from our CowSignals presentation on robotic milking, and it kind of introduces the idea of barn design. So here is this, this red and white heifer. For her to make us a lot of money, she has to get to that robot 4 times a day, 3 milkings and like to see 1 refusal. So the question is she going to do that in this barn if you look at this picture? And I'm going to give you a minute or two, actually, while I get a glass of water to think about that. And then if I can get some feedback through the chat, I'll take that, but I'll also share my thinking on it. So I'll be right back. Okay, I'm back, boss. Are you getting any feedback?
Not if there's one there. There seem to be too many cows around the robot area. Seem to be also a lot of competition around the robot. And that is at the moment as far as we got. Narrow passages.
Okay.
Cows queuing by the robot.
Okay. Okay. Well, I think good observations. I'll share mine. When we do this in an interactive setting, the first response I usually get is that this alley is too narrow, and that there probably speculatively is not a lot of space around the robot either. And so space limitations in this barn create a challenge for the heifer. Now, some of you have observed that there's too many cows standing by that robot or standing in general. And so, you might be surprised when I say I may actually make this alley 30 centimeters or 20 centimeters narrower than it is now as part of my solution. And you say, well, how can that possibly be beneficial? And when I look at this picture, the biggest problem is that there's too many cows standing up. These cows are in the way because they're standing. If they were lying in the free stalls, as more than half of them should be, if cows rest for 14 hours a day, then the width of this alley would not be an issue. A cow would have easy access to the robot. And so the problem is no bedding in the stalls. The problem is the stalls are too short. If you think about this, the speckled white cow that's looking towards us to the left of our heifer, if she were standing in the free stall because the neck rail was far enough forward and the stall was big enough, she wouldn't be blocking 1.5 to 2 feet of the alley with her butt. And so that would make the alley wider all by itself. Those stalls along the wall are very short. And ideally, my fix would be to get a sledgehammer and knock the wall out and build a new curtain wall under the eave 2 feet further out. If that's not a possible solution, then, as I say, I would probably make the alley narrower in order to make the stall longer, to make the stalls comfortable and get these cows laying down. So if I have to allocate space and come up short somewhere, give me big enough stalls, give me cows laying down and resting comfortably, and I'll deal with less space in the alleys. Because if the cows are laying down the way they should be, we're going to get way better traffic to that robot. So I think CowSignals training and CowSignals seminars are always lots of fun because we can sort of discuss these things and draw answers and conclusions from all participants, and they go home and start looking at their own barns a little bit more carefully. And I hope just spending a few minutes on that has whetted your appetite for
Or another observation that was made, Jack, was that there was poor ventilation because there's a lot of cobwebs hanging from the ceiling.
Yes, absolutely right. Absolutely right. And this is a Dutch barn, and I've done a lot of seminars in Holland, and they say to me there, well, Jack, we can't knock the walls out of these barns and let the wind blow through because it's way too windy in this country, and you don't know how windy it gets here. Well, I think you can put wind controls on curtains, but their concern is that the bedding blows out of the stalls, and they should put some in first, and maybe we actually have that problem. Anyway, let's go on and talk about barn design. And I'm going to go a little faster here because I think the slides are fairly self-evident and illustrate the points fairly well. And when I do barn design work, then I'm really looking at 4 cornerstones to a barn. And number one to me in design, the priority is cow comfort. If you have comfortable cows, you're going to have healthy cows, you're going to have high producing cows, you're going to have cows that go to the robot frequently. My second cornerstone is labor efficiency, and that has to be built into barn design. You have to work with straight lines through the barn and simple routes for feed delivery, and so on. And it occurs to me that these corners are strongly connected, because if you have comfortable cows and you have healthy cows, you don't have as many sick cows to deal with, and sick cows take a lot of time. So a barn full of healthy cows improves labor efficiency dramatically. I think you can look after 20 healthy cows in the same time it takes to deal with 1 cows with a metabolic problem or whatever. Of course, you want to get bang for your buck, so you want to spend the money in the right place where there is a payback. And cost and value to me doesn't always mean building a cheap barn. It means building a barn that provides cow comfort and labor efficiency. And then the fourth corner to me, especially in a robot barn, is that it has to be expandable. Because if you reduce your labor requirements, you're going to be able to handle more cows. And then to make it pay, especially on a family dairy where the amount of labor available is already set, you're going to have to milk more cows to gain the economic benefits. And so most of the time when I design for a client, if he wants a barn for 120 cows, we design a barn for 240. And then we take that paper drawing and say, okay, well, where are we going to cut 120 stalls off of this so that it still works and works well, but that we have things in the right place to make expansion easy to do in the future and so on. So we always get the question, do you renovate or build new? I think new always lets you do it right, and your old barn, especially if there's expansion involved, is likely an ideal place for older heifers. The stalls are too small, the alleys are too narrow. Great place to house heifers from 12 to 24 months of age. If you do decide to renovate, I want you to write down every compromise or decision you make along the way, because we tend to get so focused on how do we fix the undersized stalls and alley? How do we deal with the poor ventilation and so on and so forth? And the more focused you become on that, the more you forget that there is an alternative. And as you make your renovation plans, write them all down. And then before you push the button on it, make one final decision. Is it the right choice? Or are we better off to build something new? And yeah, a lot of now our bigger herds always are going to involve renovations because there's a lot of milking capacity there already. And I think I see a lot of dairies that just don't do a very good job. And this is classic here of the way that Americans build or renovate robot barns. They look at the barn, they don't change anything except they stick a couple of robots on the outside in a lean-to. Very inexpensive, very convenient for the dealer who probably made the plan, because he can get his chemicals in there and his techs in there and so on really easily. They don't even get any manure on their boots. But cows will not like this barn. I think farmers will not like this barn very much. And if you look at the way this is laid out, so yes, cows have free access to the robots, but when they come out of the robots, the only place they can go is back into the same space. So you have no separation capability, no way to do any handling. And so what I see in these barns, yes, we save a couple hours a day of labor of not having to milk, but we add an hour of labor running around the barn searching for cows, putting them into separation pens manually and treatment pens and so on and so forth. So I think we need to think these plans through a lot further. Here's another way I see this done, with a lean-to on the side. So here, the farmer wanted to have the ability to sort cows into a separation pen. So they put in a commitment pen. So it's a free traffic barn out here. Cows can go to the feed manger anytime. But a cow going to the robot has to enter this commitment pen. And I should go back because I didn't mean to push the button. Be milked. And then when she tries to exit through this sort gate, if she's not milked, she gets sent back. If she's milked, she can be sent back to the main herd or separated into this special needs pen. And she can go back for milking from there in that circle if you house her in the special needs area. The problem with this layout to me is this commitment pen. And essentially what we see, especially with busy robots, is that a timid cow will go in here hoping to get into the robot to be milked. But there's always a more aggressive cow coming in and keeping her out of the robot. So 2 hours later, she's tired. She's laying in a corner here because she cannot get a turn at that robot, and she doesn't have proper time to rest and eat and so on. And so these commitment pens and guided traffic both create a lot of additional stress for the cows. So I think you want to choose for totally free traffic with no commitment pen. It gives you more visits, less waiting time, also better consumer image. We call this voluntary milking, but is it really voluntary when you use a guided system? Free traffic makes it easier to manage bedding because the cows are free to get out of your way when you come through with bedding equipment and so on. And it's cheaper to build as well. So this is the barn layout that I want to spend time talking about. And so I'll take a fair bit of time here to familiarize you with it. So this one is set up for 2 robots. So we have perimeter feeding. You deliver feed on both sides on the outside. 2 robots in a line facing in the same direction in front of 6 rows, so 3 double platforms of head-to-head free stalls, fair bit of open space here in front of the robots, a fetch pen beside each robot, and then a way to sort into the space behind. And then I'll use the space in line with the center platform for a vet room or vet storage and 1 or 2 handling chutes in behind there so that you can handle a cow from any part of the barn regularly, easily. If you're a fan of management rails, you can do your group handling back here in a management rail, but most of our dairies would do it out here in headlocks instead. But The stalls, where the cows are here, you have 120 comfortable free stalls in front of the robots for the milking cows. Behind one robot, I'm going to put a bedding pack with fresh and lame cows in it that can be milked this way. Behind that might be your maternity pens. Behind that, your close-up cows, all in bedding packs that are easy to clean. On the other side, I'm going to have some flexible stalls that I can use for separation space or for far off dry cows. And I want to do the gating in there so I can change the size of those two groups at will by moving the gates up or down the page here. If you have room in the barn, you might put your close-up heifers or your oldest heifers in the barn as well. So yeah, this looks like it's going to be a new barn, but I think in renovations we can incorporate a lot of these ideas, and that would be my goal with a client doing a reno, is how much of this can I get in there? So
sorry to interfere, Jack.
Yes.
Just a little message for Colin. Colin, your camera is still on and we can see you're having a bath. Thank you.
Hi, Colin. Okay, so I think happy space in front of these robots is just critical to making the barn work. So, a large open area between the robots and the first free stalls. We're looking in North American lingo at 20 to 24 feet there. So that's going to be like 6.5 to 8 meters as the measured distance there. And yeah, how does that benefit the cow? If you are a timid cow and you're waiting here, okay, and the boss cow that's going to beat you into the robot anyways comes from here, you have lots of room to escape in this direction. In fact, this is wide enough that she probably isn't going to bother you at all. If she's coming from the other side, you can escape in this direction. So large open space, but also open space with escape routes, not a dead end space, okay? And then in order to only have cows hanging out here when they're waiting for milking, I think your cow brushes, your pasture selection gates, your computer feeders should be as far away from this as possible in order to spread out activity across the barn. And as I mentioned earlier, don't make this the best ventilated spot in the barn either. You want cows to come here because they're coming for milking. Now, many cows like to have a drink right after milking. So I do always include a big water trough on the opposite side of that crossover. So I like wide open barns with a minimum amount of gating, but one place I do want to gate off is that space right at the exit to the robot. So I don't want that cow standing right in front of the robot looking to eat some spilled grain, or she may be an untrained cow that actually was in a group, the lactation before the robot on the other side. That's one of the benefits I see of having all the robots facing in the same direction, is that cows are used to where they enter and where they exit. But by putting a 2 meter long, 2.5 meter long exit lane at the end of the robot with a one-way gate on it, you ensure that a cow can exit the robot, stand in that space, and negotiate the exit back to the barn while the next cow is being milked. And that's going to improve your visits and give her a better chance to decide when she wants to deal with the bully that might be standing out there looking for her and so on. This also works in very conveniently with a separation gate, and you can see there's one there directing cows into the space behind the robots. All the metal near the robots needs to be smooth welded and not clamped. These are high traffic areas. There's cows going to be bumping this stabling all the time. And so you don't want any bolts sticking out anywhere if you want to avoid injuries. The second point in this barn design is that I want you to have this low stress handling of the fetch cows by coming up with the right kind of fetch pen. So these fetch pens here are what we call split entry fetch pens. It's a design that I actually developed back in about 2020. Took a little while to convince Lady that it was the right answer, but I see them used sort of worldwide now. So what this split entry fetch pen allows is that the milking cow coming straight from the barn still has direct access. The cow you've put in the fetch pen can push that free swinging gate the other way and actually have slight priority. So she has a slight advantage, and I think that's a good thing because it's the timid cow and the lame cow that you're putting in that pen. But you are not preventing cows from going to the robot. So you can be much more comfortable about leaving a cow here and not chasing her in manually, because she can get there on her own time without interfering with other cows in the barn. So yeah, what are the pluses of this in terms of thinking about progressive teaching? You know, if you have a cow that's never seen a robot before and you put her in this pen and you pull this training gate up beside her, okay, now when the robot opens, it's very easy for you to just push her in. And you know, if that free swinging gate actually can be tied to the left-hand post there so that the cows from the barn don't have access, that's going to make that easier yet. Okay, the second day, you can put the cow in this corner and put a chain across between those two gates and leave her standing there. Now she has to make the last step on her own. And the third day, you leave her in the fetch pen and hopefully she can figure it out. And then maybe the fourth day, she can graduate from kindergarten here into the herd and seek her own route. If you don't have a well-designed fetch pen, then before you go for breakfast, your temptation is going to be to chase that cow into the robot. And now you've taught her the wrong thing, because you'll be chasing her into the robot for the rest of your life. These kind of split entry fetch pens are actually associated with higher production per robot in a Dutch study that was done 5 years ago. So I thought that was quite interesting. Okay, so point 3 for this barn design: behind one of the robots, I want to have a comfortable bedding pack, straw bedding, shavings, whatever your choice is, with easy robot access for fresh cows and for lame cows. So, you know, if a lame cow doesn't come on her own, this is the lowest labor place to fetch her from. She's going to have the opportunity to lay in any direction she wants, and that's going to be healing compared to having to lay in a freestall. You know, a fresh cow that may still be compromised and may still have some pain for a couple of days in this pen, I think is going to work very, very well. And, you know, the plus is that they do have free access to the robot. They have access to feed and water. You know, and a cow that's in this pen that goes to the robot 3 times a day without your help, that's probably a pretty good signal that she should be moved out into the barn. How much of this space do you need? I think with the 120 cow herd, probably room for 3 cows. So 3-4% of the herd at most will do. The pens behind that might logically be calving pens, and the pen behind that might logically be a close-up dry cow pen. And so cows don't have a big change in environment. They can see each other. Minimum stress in this period before and around calving is always going to be a good thing. So you have a stress-free progression from a close-up pen to calving space to a fresh cow group in that space. And yeah, this is a great place for them to recover and heal from injuries. It minimizes walking distances and makes fetching as easy as possible for you. Another point is computer-directed footbath access. from this space as well as from the barn. And I talked about this in my earlier session already, how you can set that up with a refusal through the second robot and still only limit yourself to 1 foot bath in a barn this size. And there's that corner layout as well, so no need to repeat that. I want barns, especially here in North America, where we're using a fair bit of big equipment, and especially on bigger dairies. I want you to have straight open alleys through the length of the barn. So the green lines are feed alleys, the purple lines are bedding alleys, and there's nowhere where there's a robot or a lot of gating and so on in your way. It's very easy to move through these barns in straight lines. And like bedding activity disrupts the barn, and where it can't be done quickly and conveniently, we see a reduction in the number of robot visits on bedding day. In a barn that's laid out this way, you open the door, drive in one end, swing a few gates as you go. With 2 people, you can bed the entire length of the barn in probably 5 or 6 minutes or less. So that's really, really important. And I think it works better with free traffic as well, because you're not chasing a bunch of cows through a one-way gate they can't get back through. Ideally, we might want to automate bedding delivery completely, so we don't have to drive into the barn with equipment. We have some of these track-mounted bedding systems. We have them for sand, we have them for straw shavings. We do have barns where we automate this and actually close the curtains before we put the bedding down, because it does blow around when it's coming from up high. And if you put it on the cow's back, she takes it with her when she goes into the alley. I think there is a Swiss company now that's developed software that can identify whether there's a cow in the stall or not. And it will skip bedding a stall with a cow in it, and then go twice as slow there the next time through and put twice as much bedding in. But those are interesting sort of new technologies coming along. I want to talk about handling individual and small groups of cows in a robot barn. And, when you sort out a robot exit over 12-hour periods, you can collect cows for handling. But it's more complicated than in a parlor barn, where you would do that over a 1-hour milking time for a group. But you can sort into a space with feed, water, resting area, and milking access, so that the cow that you separate 12 hours before you need her can go back and be milked 6 or 7 hours later. And you want this to have good access to a chute or handling space for hoof care and other treatments and so on. So that separation area is shown here as a couple of free stalls over here. Okay. Or you could also choose to separate into this space as well. You'd have the flexibility to do both. Those cows would eat where the green line is. So there's a cow entering that robot for milking, getting diverted into the space. A cow in that robot gets diverted through the footbath into that space. They can be milked in that robot by having access to that fetch pen and be returned back to the same group. If you make this space flexible, so right now I'm showing 2 stalls here used for separation and a large number of far off dry cows. Now, when you need to separate 15 or 20 cows because it's herd health day, I have a number of farms that will move as many of the far off dry cows as feasible to the close-up group here, okay, here. Then, because they have fewer cow numbers here, they'll move these gates in this direction to crowd the far off dry cows for one night and create 10, 12 or so stalls here that they can separate 20 cows from the milking herd into. And then, so that's set up as it is shown here. and then they can run them through that management rail or through the working chute and return them back to the part of the barn where they need to go to. So that minimizes sort of walking for the vet. It makes sure that every cow you're looking at is a cow that requires treatment, and it doesn't disturb the cows that you don't need to handle. So I see advantages for that over, say, locking up all the cows in headlocks when you're only looking to preg check 20% of them, and you're walking by the others with an armful of drugs and so on. Individual cows, you're going to handle in a chute. And I think every robot farm should have someone on the premises that understands basic hoof care, so that you can look at a cow that's limping that day and not wait for somebody else to show up. I would include a computer in your equipment storage and have water and electricity or a full-fledged veg room, because this is where you're going to use that equipment most. Rule of thumb should be one man, any cow, in 1 minute into a handling chute from anywhere in the barn. And so if it's in the center like this, it's accessible to all groups of cows, and you may get a better understanding now of why we love perimeter feeding so much, because none of these cows have to cross an alley to get into that space. And the gating should be designed so that one person working alone can move any cow to the chute without causing a lot of stress and so on. Headlocks, I think I would still want them in a barn. It's the most convenient way to flame udders, and still a pretty good way to do reproductive herd health and so on if you don't want to separate all the cows. Of course, a 6-row barn does not have enough headlocks to lock everybody up. And so to stay with that 6-row design, if you have enough gating here and here to lock these cows back, you can use headlocks in this space. You can use headlocks in this space as well, and conveniently lock up all your milking cows at once when you choose to do that. If you have room for your oldest heifers in the barn as well, and you have a day that you're not super busy, you can take that heifer into the fetch pen and expose her to the robot and give her some training. Teach her that there's nice grain to eat there, that there's some spinning brushes and some noises, and you will reduce the stress on that cow at calving if she's had that experience a month before as a heifer. So yeah, perimeter feeding makes access to central handling convenient and possible. It makes the barn a couple of meters wider than a center drive-through, but it also improves cow comfort tremendously, because you never have rain in the stalls. You never have sun in the stalls. You don't have sun in alleys drying them out excessively and making them slippery and so on. You don't have frost in the manure alleys. So it's a little bit more expensive barn to build, but very, very convenient to work in and so on. Expandable robot 3 and 4 are going to go on this center platform. And, I think you can face them in opposite directions so that these cows flow this way, these cows flow that way. And you can still sort into this space, but it's a little bit more complicated. This cow can go directly in. The cow from here would get sorted into this fetch pen and then be refused in this robot and back into the space. So yes, we can make it do all of the things even in this bigger layout. So here it is, 8 robots, 500 cows by mirror imaging the 4 robot barn on the other side. There's 1,500 cows and a dry cow and transition barn in the middle. And what a lot of our larger herds are now doing, they want to tunnel ventilate this thing crossways. So they set it up so that all of the handling and all of the separation is at one end of the barn. And there's a row of 2 robot 120 cow groups. And we'll have barns that have 12, 14, 16 robots set up that way and just get the maximum ventilation airflow for their electricity dollar in that. So just to very quickly summarize, I want you to look for free traffic, lots of open space in front, footbath beside or around the corner in the robot, all the robots facing the same way, preferably a simple route for fetching, simple routing to move cows from one group to another, a convenient handling chute in the center of the barn, gating that one person can move cows easily, a flexible separation area, and a pack for fresh and lame cows. That stress-free calving line in a small barn that you can have the close-up cows very close to where they're going to calve and very close to where they're going to be introduced to milking, and then perimeter feeding to make all of that gating work. And if you need two things to focus on, it's got to be cow comfort, it's got to be convenience in handling the cows. So I'm going a little long, and my apologies for that, but open to answer any questions you have.
Okay, thank you very much, Jack, for your very in-depth presentation, and about also the kind of the cow comfort is key and also convenient of handling. My question from earlier, you kind of answered during your presentation about, do we use self-locking yokes or a separation area? And it probably sounds like it's best to have both.
Well, I think that I actually have some clients that have both. And in the majority of cases, they make very little use of their headlocks. A lot of them will use the headlocks more so that the access to the manger is consistent, and they actually use headlocks in the separation area to do their handling. But yeah, if a cow never sees a headlock, then you really better not choose that option, because some cows really won't know how to use them. Yeah, this is maybe a little bit overly philosophical, and I might lose someone in it, but all of our lives, we've been taught that you should not treat a cow in the milking parlor, because that's supposed to be a happy place. So then does it follow that we shouldn't lock her up at the manger and stick our big fat arm up their rear end a couple of times to make that an unhappy place? They're there to eat, and we want them to eat as much as possible. So I'm quite content to have no headlocks in a barn. I know cows will not be happy with you when they get separated and get chased to a handling chute or a management rail, because they know ahead of time to expect a bad experience there. But better to have that than to have them wonder if they're going to have a bad experience at the feed manger.
Okay, thank you very much. There's also a question from the chat from, in your opinion, what's your opinion on slatted floors, in particular, the effect on hoof health versus automatic scrapers?
Yeah, well, I mean, I think in our experience, slatted floors that don't have some kind of scraper on top, preferably a robotic one, but they're going to get way too dirty in a modern barn, because, you know, cows used to stand and walk around a lot, and that cleaned the floor. But if you are providing cow comfort, you're going to have way too much manure laying up on top of those slats. And so you will need a slat cleaning device in those barns. Personally, I think that slatted floor barns are certainly manageable. Yes, a cow that has not been on them could develop some feet and leg issues. But, you know, people with 10 years experience with slats, those cows are gone, and the cows they have are fairly well adapted, and those barns don't have really any more lameness than barns with alley scrapers. Alley scrapers, I can see issues with automatic alley scrapers that you have this constantly moving manure bath moving through your barn. And if cows don't have lots of escape routes and stalls they can step into, you end up with a lot of cows with even dirtier feet because this manure bath moves through underneath them. We have now adopted two different systems that avoid that. One of them is a tube under the floor where the alley scraper now becomes a collector that draws the manure to the center. It drops down through a 2-inch gap, and most of it moves to the end of the barn through a 1.5 foot square pipe under the floor. And we're happy with some of those. And then, of course, I also get very, very good reports on the Discovery 120 manure sucker systems from Lely. We've been doing some work with them in sand barns as well. The biggest limitation to me for a slatted floor barn is that my clients who have slatted floor barns do not want to use sand in their free stalls because there's no way to get it out of the pit, or no simple way. And I am a huge believer in sand bedding. So if I were building a barn for myself or making recommendations to a client, it would be sand bedded free stalls and alley scrapers, or perhaps sand bedded free stalls and Discovery 120s today.
Okay, and another question in the chat from how many cows are too many in one milking group?
Okay, that's a really interesting question, and very few people have any useful experience at answering that question. I do have one client that started with 6 robots in a slatted floor barn with 6 robots in the center, so 3 facing one way, 3 the other way, 180 cow milking groups. He took out long A3s and put in shorter A5s and had room to put in 4 on each side. So his initial experience was to go from 3 robot groups to 4 robot groups. And then, of course, because with 4 robots, you can split it in the middle, he also had the option then to go back to 4 2-robot groups, which he did, which he is now doing, which he is totally convinced is the best group size. Now, if you only have 1 robot in a group and that robot goes down, you have cows that wait and wait and wait. If you have 2 robots in a group, and especially if they're not linked to the same central unit, then your cows have a little more choice, and you get a few more milkings out of that 120 cow group than you would out of 260 cow groups. Fetch cows are still relatively easy to find. If you go to 3 robots in a group, 180 cows, now finding those fetch cows adds substantially more to the labor in my mind, and also of this client's mind. So even in a very large herd, if it were convenient for me to do so, I would plan to have a whole lot of two robot groups of 120 or so cows.
Okay, thank you very much for Jack. That were all the questions from the chat. I don't know if anybody else have some last burning questions for Jack, and is happy to open their microphone and ask Jack the question. Then you're free to do so now. And if there are no more questions, then on behalf of Lely Center, Devon and Cornwall, I would like to thank Jack for tonight to give this fantastic presentation and his insight on how to make robotic milking successful. And I also want to thank everybody for turning up tonight.
Okay, well, I also want to thank all those who participated, and I want to thank Lely Center Devon for the invitation. I'd much rather be there to present in person, and hopefully someday the world will change back to that for us.
Well, you're welcome to come over here, Jack, when everything is settled down.
All right.
So I will stop the recording now, and people are free to leave, or if you have any last questions for Jack, please do so. Thank you very much.